The last shape we'll be finding the volume of is a sphere. So you can think of a sphere just as a three-dimensional ball, and the formula to find the volume is here. Okay, so volume is going to be equal to 4/3, and then it'll be multiplied by pi, multiplied by r cubed. And this is the thing that people, if they mess up on this formula, this is the place that they mess up on the most. Sometimes, or a lot of times, I see people forget to make this cubed and they make this squared instead because they're used to the formula pi times radius squared. So be careful here for spheres that you always make this cubed. Okay, this is to the power of 3. All right. The only thing that we really have to distinguish when we are finding the volume of a sphere is if we're using the radius or the diameter, okay? So for this formula, the only number that we actually have to plug in is the radius. That's the only thing we need to know, and then we just multiply all of those numbers to get our volume, okay? So just be careful. If you're given a diameter, make sure you're using the value of the radius. You're using half of that diameter, okay? So for example, if we look at this problem and we're trying to find the volume, it would be 4 divided by 3, so 4/3, times 3.14, that's pi, multiplied, and then this is definitely the radius. It's from the center point to some point on the sphere, so that's 2.5, and then we make sure 2.5 is cubed to the power of 3. So plugging that all in, I get 4/3 times 3.14 times 2.5 cubed. Okay. Volume equals 65.4. Awesome. And then inches cubed. Looks great. All right, so now that we have that, the volume of this sphere would be 4/3 times 3.14 times the radius. Okay, so right now we have the diameter. Instead, we want to know what half of this is. So if we take 18.2 and divide that by 2, I get 9.1 for the radius. So 9.1, and then we make sure that is to the power of 3. So all of that together, 4 divided by 3 times 3.14 times 9.1 cubed. And we get 3,154 point, and then I noticed that I have actually 9/5. So if I round this to the nearest 10th, since there's a 9 and a 5 after this, the 5 will round up, making this 10. So then that 10 will add up here. So then this will turn to, instead of 4.9, it will become 5.0. So let's change this here to just that. So 3,155 millimeters cubed. The other thing I'll briefly mention is what's called Cavalier's principle, which basically think about it like this, okay? Say you have a stack of coins, okay? So a bunch of coins all stacked up. If you were to find the volume of this, because this would be a cylinder, right? Like this would be most comparable to a cylinder. It has a circle for the base at the top and at the bottom, connects between the two, right? Say we found the volume of this. We found that the volume was like 100 something, right? If you tilt the coins, if you knock them over a little bit, does the volume change? So if you knock over the coins a little bit, does the volume change? So according to this principle, the answer is no. The volume still stays the same. I still have the same amount of coins. I just move them a little bit. So they still take up the same amount of space or volume, even if I just move them over a little bit. So basically, we can think of like that applies to any of these 3D shapes that we've been working with. Like, let's say we had a rectangular or square prism, and if we found the volume of this and then kind of push them over as if they were like coins and stack them all over the place, move them around everywhere, it still has the same volume as what this would have. Okay, same thing with the rest of these shapes.